3 of the MTH312 Midterm 2, and it says evaluate the inverse Laplace of s plus 1 over s squared plus 2s plus 1, all of it squared. So how do we solve this question? Well, the first thing that we should do is we can try simplifying whatever this is. And so we can see that in the denominator, we can probably try to simplify this. So we know that we have s squared plus 2s plus 1. And let's set that equal to 0 and factor. Our product is equal to 1. Our sum is equal to 2. The two numbers are 1 and 1, and so this is factorable. And so we can factor it s squared plus s plus 1 is equal to 0. Factor this, we have s plus 1 plus s plus 1 is equal to 0, and we end up with s plus 1, which we can rewrite as s plus 1 squared, and that is equal to 0. So we can rewrite now the Laplace, the inverse Laplace. So we can rewrite it as s plus 1, and since this s plus 1 squared is going to be squared, this technically turns into s plus 1 to the power of 4. And so we can cancel one out since they're the same thing. So we can cancel this, and so we're left with the Laplace inverse of 1 over s plus 1 cubed. So now there are multiple methods to doing this. There is a way to do this with convolution. There is a way to do this with the transformation theorems that you learned earlier on. There's even a way to do this with the derivative Laplace theorem. And so that is what I'll be showing. So what we can do, the way we can solve this is, let's think as if this function is the derivative of a function. What could be the base function? Well, we know that the Laplace inverse of 1 over s plus 1, right? This is easy. We know that this is just e to the power of t, e to the power of negative t. So if we were to then differentiate this, we would have s plus 1 squared in the denominator, and you can go ahead and actually check that. What we need is a cubed, and so we can go ahead and write, let's do the Laplace inverse of t squared. Let's find the Laplace of t squared e to the power of negative t. So theoretically now, if we were to go ahead and find this Laplace, this should give us something similar to what we are looking for right here. So let's go ahead and actually now evaluate this. So then, let's make some space. This would be equal to what? Well, remember that this is a theorem. This theorem, if you recall, is Tn times f of t, and it will give you 1 over s times f of s. This is what we get with this theorem. So let's go ahead and solve for f of s now by using f of t. Oh, this is the wrong theorem. you will get 1 over n f s. This is the theorem. Mixed it up, but this should be it. So we have to find f of s first. So let's go ahead and do that. So we know that in this case, our n is now equal to 2, so we'd have 1 over 2. And then we would have e negative t. Well, we know that is just 1s plus 1. But now we have to differentiate it twice. So I'm gonna skip the differentiation. If you guys do that on your own, you should be able to get what I get. So let's skip that and we'll get 1 times the differentiation. Once you differentiate it twice, you should get 2 s plus 1 cubed. And that is just equal to 2 times 1 over and this is what we get. Now we can see that we literally have found what we are looking for, the 1 over s plus 1 cubed. However, we have a 2 that is being multiplied to it. What does this mean? Well, recall that we are trying to find the Laplace inverse of s plus 1, s squared plus 2s, or, you know, once you simplify it, essentially 1 over s plus 1 cubed. And so if we have just successfully found that the Laplace of t squared e to the power of negative t, right, is equal to 2 times 1 over s plus 1 cubed, then all we have to do to find out what is equal for 1 over s plus 1 cubed would just be to move this 2 on the other side. Simple algebra. So that would mean we would have 1 over 2 Laplace of t squared e negative t, and this would be equal to 1 over s plus 1 cubed. And so since this 1 over 2 is a constant and this right here is our f of t, we can multiply that back in, meaning that the Laplace of 1 over 2 t squared e negative t is equal to 1 over s plus 1 cubed. And so what is our f of t? Remember, we're trying to find the Laplace inverse. So this expression right here, we can just rewrite it. Laplace inverse of 1 over s plus 1 cubed is equal to our f of t, and that is equal to 1 over 2 t squared e to the power of negative t. And that is one method of solving this Laplace inverse question.